The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I was wondering that you all have given me the revision answers and I've done almost 70%. Please excuse me, bear with me that I couldn't call you, but definitely I am planning to do it during this weekend. That is by tomorrow or by Saturday. I'll give a personal call to you to give a feedback about the revision answers that you have done. Most of you have done very nicely. There were some of the silly mistakes I could see, so you can just rectify it, because when we do mistakes, be happy children, because we don't make that mistake again, right? So we have completed almost 5 chapters now, right? So we are getting into the 6th chapter, and the bullet points I'll be sending you for the 4th and 5th chapter very soon, so you can have a look on it. And our 6th chapter is quite interesting because it deals with extraction of metal, purification, refining, which you have already studied in your 10th standard, if you remember, in production of metals, right? The topic is general principles and process of isolation of elements, right? So here we are going to start with the basics of ore, mineral, metallurgy. We know there are a lot of minerals in the earth's crust. So any mineral that has the most metal content, you call it as an ore. So from the ore, you are going to get a pure metal, and that whole process we call it as metallurgy. So in metallurgy, what happens exactly? We have concentration of ore, we have isolation of the metal, and we have purification of the metal. Today's class we will focus on concentration of ore, and then we will get into the rest of the parts. What is concentration of ore means? In concentration of ore, we are going to focus on removing the impurities, because any ore which has a metal content in it will not have only the metal but will also have earthly impurities like gangue. We were discussing in 10th standard, you remember? Sand particles, dust. So those particles we call it as silicon dioxide, that is gangue. So in this first process of concentration, we are going to learn about hydraulic washing, front flotation, magnetic separation and leaching. These are the 4 methods involved in the concentration of ore. Any ore that is available, if you see children in the nature's earth's crust, there are a lot of ores available, metal. But when we see, aluminium is the second most abundant metal available in the earth's crust, and iron is the 3rd most available metal in the earth's crust. There is a table given to you in the textbook 6.1. The first table where you have the metal, its ore and the chemical formula, that is the composition. Please learn the metal with its ore because it comes in 1 mark question. So do not lose your 1 mark. So it's very important and you have to learn it by heart. Okay, so now we shall start with concentration of ore, the 4 methods. Now we will start with concentration. What is concentration of ore? As I told you, ore will be having the metal along with some impurities. But we don't need the impurities, so the impurities have to be removed. So the first step of metallurgy. What is the first step of metallurgy? Metallurgy is the process of refining the pure metal through several steps. Right? In that the first step is concentration, where we are going to remove the impurities. That is, we are going to dress the ore. So the process is also called as dressing or benefaction. On what basis do we select the method? Because there are 4 methods. So depending on the physical properties of the ore and the gangue, that is impurity, we select the method which we want. So the first method is hydraulic washing. In hydraulic washing, the difference will be in the weight of the ore, or I would say the gravity of the ore. More the weight, it will settle down at the bottom, less the weight, it will float on the top. So here the ore is heavy and the gangue is, that is the impurity is lighter. In hydraulic washing in 10th standard, if you remember children, water will be sprayed from the bottom. The ore and the impurity will get mixed up. The ore being heavier will come and settle at the bottom. The impurities being lighter will float on the top and will be washed off. That is, will be removed. That is the process of hydraulic washing. The next method is magnetic separation. From the name, it is very clear that it is based on the magnetic property. Either the ore will be magnetic or the impurity will be magnetic. So depending on that, we will be selecting the magnetic separation. Where you have a conveyor belt, the diagram is given in the textbook. The ore will be poured from the top. When it passes over the conveyor belt, what happens? There will be 2 boxes. The one which is magnetic in nature will come and settle here. The one which is non-magnetic cannot pass through the belt, so it will be collected separately in a container. So this is mainly used for substances which are magnetic in nature, metals which have the magnetic property. The next one will be froth flotation and leaching, which we will learn now. The next one is froth flotation. What do you mean by froth? Froth means foam that comes when you just rub to the soap. What you get froth, right? That is foam. Now froth flotation method is a beautiful method which is used only for separating sulfide ores. That is for treating sulfide ores. Here the ore will be mixed with water. See, this depends on the mixing with oil and water. So ore will be mixed with water and we use collectors. What is the use of collectors? It starts collecting. What it is going to collect? It will collect all the impurity. Because collectors like pine oil we will add to enhance the non-wettability of minerals. Which means my ore will be mixing with water, but ore do not mix with collectors. But the impurity will be soluble in oil, but do not mix with water. You understand children? So what do? You mix the ore with water, you add collectors. So collectors will collect all the impurities. You add froth stabilizers like chrysols and aniline, because there will be a paddle, rotating paddle there, which will be rotated. So that will create the foam. And what happens? Once the froth is created, it will collect, the collectors will be collecting all the water separately. That is, it comes out and then the gangue will be removed separately. See, to enhance the non-wettability of the minerals. So both the cases are possible. If the ore can be soluble in oil, the froth will rise up, it will take all the ore particles outside and the gangue will settle at the bottom. Right? Because it do not mix with the oil. So there are 2 methods of doing it. The purpose of collectors is to collect all the ore separately. If the ore can be mixed with the oil or if it sticks to the oil. And we use froth stabilizers like aniline, which is used to develop the froth. Now if there are 2 sulfide ores, can it be separated using this method? Yes, definitely. It can be separated by adding a depressant. What is the use of a depressant? The depressant will allow only one sulfide ore to form froth. It will not allow the other sulfide ore to come closer. Example, like sodium cyanide, if it is added to a mixture of zinc sulfide and lead sulfide, it will allow only lead sulfide to froth and it will not allow the zinc sulfide to come closer. So that is how froth flotation process is used for separating the sulfide ores. The next method which we will be seeing is leaching. This we have learned in 10th standard. If you remember children, bauxite is the ore of aluminium. Directly bauxite we will not use for extraction of aluminium. So we will convert bauxite into alumina. So this is the process of leaching where bauxite ore will be treated with sodium hydroxide hydroxide, concentrated sodium hydroxide in presence of water. Once it gets dissolved, you get sodium aluminate. Now that sodium aluminate will be neutralized by passing with carbon dioxide so that the impurities will be removed separately and you get alumina with the water content, the moisture content will be present. So these impurities which will be remained in the beaker will not be disturbing, but once we get this alumina with the water content, that will be heated separately and that will be dried out to get the alumina where the moisture will be expelled out. So this is the process where the ore must be soluble in a suitable solvent. Here the solvent that we take is concentrated hot sodium hydroxide solution. So the steps, if you can by heart, that is better, because they ask this leaching method often in the board exam, children. Because leaching method is nothing but difference in solubility. That is, the ore gets dissolved but the impurity do not get dissolved. So that will be remain as settling down at the bottom, which will be filtered off with a filtrate. Right. So this is the method of leaching. Now we'll get into calcination and roasting. With that, we'll stop the class for today. Yes, now we have two more things, that is conversion to oxide and reduction of the oxide to its metal. This is also what we have learned in 10th standard. We just refresh ourselves. Two methods are there for conversion to oxide. First one is calcination, the other one is roasting. Calcination and roasting involves heating process. The simple difference is, in calcination we don't use oxygen or we use limited supply of oxygen. But in roasting, we use enough oxygen for the heating process. So in calcination, zinc carbonate will be heated. That is, the carbonate hydroxides can be heated in the absence of air or with limited supply of air to form its oxide. Where you can see zinc carbonate getting converted to zinc oxide. Fe2O3 hematite with water content giving Fe2O3 alone. Right. Next is roasting. In roasting also we are going to heat the sulfide ores in excess of oxygen to get converted to its oxide form. The example given is zinc sulfide plus oxygen giving zinc oxide plus sulfur dioxide, where this can be used in the process of manufacture of sulfuric acid. But if our ore is iron and if it has some sulfur particle, what you can do is you can treat it with silica to form the slag, from where you can convert into its oxide form. So these are the two methods where we heat the ore below its melting point, either in the absence of air or in the presence of air. The next method is reduction to the metal from its oxide form. We know, children, if we want to reduce to its metal, we need to use reducing agents. Reducing agents, we have learned there are three important reducing agents: carbon, carbon monoxide and electricity. And we also learned that electricity is used as a reducing agent only for highly reactive metals. Otherwise, we can use carbon and carbon monoxide. If you remember, in extraction of iron, we were using coke. We use carbon monoxide as a reducing agent. In aluminium, we were using electricity because aluminium is highly reactive. If you see, this is a formula of any oxide which, when combines with carbon or carbon monoxide, give the metal, that is, oxide of the metal gets reduced to its metallic form, liberating the oxygen. Here you get Fe2O3, carbon monoxide acting as reducing agent, giving iron metal and carbon dioxide. So depending on the formula of the oxide, we will be getting the metal and the byproducts. I hope you have understood today's class, where we learned what is metallurgy, what are the four different concentration methods, what is the conversion to its oxide and the reduction of the oxide to the metal. I will be giving videos along with the separate methods, and then we will focus on the next topic in the next class. So until then, take care, children, stay home, stay safe, bye.
Methods of concentration of ore. Ore that is mined from the earth's crust has certain unwanted materials mostly in the form of silica and earthy impurities. These impurities are called
Gangue.
gangue needs to be removed from the ore in order to concentrate the ore with a higher percentage of metal. This can be done by various methods. Generally, any process of removal of gangue from the ore is called concentration of ore. It is also called ore dressing or ore benefaction. It is carried out as the first step in any ore extraction process. The principle of concentration of ore is simple. There is a difference in the properties of the ore and the gangue present in it. The different methods of concentration are based on this principle of difference. Methods of concentration include hydraulic washing, froth flotation, magnetic separation, and leaching. Click each tab to learn more. Hydraulic washing is a type of gravity separation which is based on the principle of difference in the gravities of ore and gangue particles. This method is preferentially used to concentrate the ores when the gangue particles are lighter than the ore particles. It is used to concentrate oxide ores such as hematite and native ores of gold and silver. Hydraulic washing takes place in a hydraulic classifier. Here, water is used to wash away the lighter ore particles from the heavy ore particles. The hydraulic classifier has a big conical reservoir with two inlets, one at the top for powdered ore and another at the bottom for water. Did you know a classifier is always conical in shape? This shape minimizes the speed of jet of water as it reaches upwards and thus prevents the removal of ore particles with the heavy flow of water. The classifier has one outlet at the top for the lighter gangue particles and another outlet at the bottom for the concentrated ore. The powdered ore is dropped in the classifier from the top and a jet of water is released from the bottom. The jet of water thoroughly mixes the content. With this flow of water, the lighter gangue particles get washed away from the outlet at the top. The heavier ore particles settle at the bottom and are collected from there. In this way, the ore is concentrated by hydraulic washing. Froth flotation is based on the principle of differences in the wetting properties of ore and gangue particles. This method is preferentially used to concentrate ores when gangue particles can be wetted with water and ore particles can be wetted with oil. This method is used to concentrate sulfide ores such as copper pyrites, zinc blende, and galena. A mixture of powdered ore and water is added in a flotation tank. A collector and froth stabilizer is then added to this ore-water suspension. Collectors such as pine oil or fatty acids are added to enhance the non-wettability of ore particles by water. Froth stabilizers such as aniline or cresols are added to stabilize the froth formed in the process. The ore-water suspension is agitated by a rotating paddle or agitator, which results in the formation of froth. The ore particles, which are wet by oil, become lighter and move towards the surface along with the froth. The comparatively heavier gangue particles remain in the water and slowly settle at the bottom. The froth is transferred to a separate container. It is then collected, filtered, and dried. Magnetic separation is based on the principle of differences in the magnetic properties of the ore and gangue particles. This method is preferentially used to concentrate the ores when either the ore or gangue is magnetic in nature. It is used to concentrate the ores with magnetic impurities such as the magnetic iron tungstate from the non-magnetic tin stone. The apparatus used for magnetic separation contains a leather belt moving over two rollers, one of which is magnetic. Powdered ore is dropped over the moving belt. The magnetic particles of the ore are attracted by the magnetic roller and tend to travel with it for a longer distance. The non-magnetic particles, on the other hand, have no stickiness. They just fall off to the container below. Leaching is based on the principle of difference in the nature of solubility of the ore and gangue in a certain solvent. This method is preferentially used to concentrate the ores when the ore is soluble in a particular solvent but gangue remains insoluble. It is used to concentrate the ores of aluminium, gold, silver and other metals. For example, let's see how argentite, an ore of silver, can be concentrated by leaching. Argentite reacts with 0.5% of sodium cyanide solution in large tanks to form a soluble sodium dicyanoargentate complex and sodium sulfide in solution. The solution is heated with zinc dust, which displaces silver from the solution in the form of a precipitate. This method is also known as the cyanide process, as sodium cyanide is used as a solvent for leaching.
Reducing oxides to metal. Impure metals are extracted from their respective ores. To obtain their pure form, they undergo a series of physical and chemical processes. There are four main steps involved in the conversion of ore to its pure metal, namely, concentration of the ore, conversion of the concentrated ore into oxide, reducing the oxide to the corresponding metal, refining of the impure metal. In this topic, we shall learn how a metal oxide is reduced to metal. The method for reducing a metal oxide to its corresponding metal is based on the position of that particular metal in the metal reactivity series. If the reactivity of the metal is low, then the metal oxide can be reduced to metal by heating it. This process is called thermal decomposition. If the reactivity of the metal is moderate, the metal oxide can be reduced to metal by using a suitable reducing agent like carbon. And if the metal is highly reactive, then the metal oxide is reduced through the process of electrolytic reduction. Now let us understand each of these methods with examples. First, let us look at how metals are reduced by thermal decomposition. In thermal decomposition, oxides of metals with low reactivity, such as gold, silver, and lead, are heated in the presence of air.
Occurring elements or compounds found within the Earth's crust. Ores are minerals containing a high content of a metal. Metallurgy is the process by which metals are extracted from their ores. Metals can be extracted based on their reactivity. Metals of low reactivity such as mercury, silver, and gold are extracted from ore by heating. The ore of mercury is called cinnabar and has a chemical formula of HgS. When cinnabar is heated, it will be reduced to metallic mercury. Moderately reactive metals such as iron, zinc, and lead are found in ores as sulfides or carbonates. Sulfide ores are oxidized by heating excess air during a process called roasting. Zinc sulfide is heated in the presence of excess oxygen, which will convert it to zinc oxide. Carbonate ores are oxidized by heating in limited air during the process of calcination. Heated calcium carbonate will oxidize as calcium oxide. After roasting or calcination, the newly oxidized metals will be reduced through the process of smelting. Zinc oxide can be heated with a reducing agent coke, which is simply carbon, and reduced to metallic zinc. Highly reactive metals such as potassium, sodium, and calcium can be extracted through electrolytic reduction. Sodium metal can be extracted from its ore, sodium chloride, using electrolytic reduction. In an electrolytic cell, sodium will collect at the cathode, while chlorine will collect at the anode. Summary: minerals are the naturally occurring elements or compounds found within the Earth's crust. Ores are minerals that contain a high content of a particular metal. Metallurgy is the process by which metals are extracted from their ores. Metals of low reactivity are extracted by heating. Metals of medium reactivity are extracted by roasting and calcination. Smelting is the reduction of roasted or calcinated metals.